Assalamualaikum. I am Tasfiya Tassim, Electronics and Communication Engineering Discipline, Khulna University. I am going to present our paper entitled GWO-XGB, that means Gray-Wolf Optimization Based Extreme Gradient Boosting for Hypertension Prediction in Bangladesh. The other authors and co-authors of this paper are Khondokar Mirajul Mumainin, Farhana Tajmin Pinky, Anamika Bishwash Tuli, Shahriyar Shiকদার, MD Ashfiqur Rahman, Abdullah Mamun Bulbul, and MD Abdul Awal. They are from Electronics and Communication Engineering Discipline, Khulna University, Computer Science and Engineering Discipline, Khulna University, and Development Studies Discipline, Khulna University. Firstly, I will give an introductory discussion on introduction and background study. After that, I will discuss the research gap with objectives. Then I will represent the proposed methodology. And finally, I will conclude with the result analysis and conclusion. We know that hypertension is an important medical and public health issue nowadays, and it's a major cause of premature death worldwide. As we can see that globally 9.4 million people become the victim of this hypertension every year. And in the Bangladeshi scenario, we can see that 20% of adults and 40 to 65% of aged people suffer from this hypertension. And the mortality rate is still very high. But unfortunately, half of the adults with hypertension are properly diagnosed and treated, because it's actually time consuming to manually detect hypertension. So for that reason, to solve this problem, we are proposing our machine learning based hypertension prediction technique that may decrease the mortality rate as well as our hypertensive patients. Here are some background studies, or we can say related works. Reference 3 used artificial neural network based medical decision support system, and backpropagation algorithm was used to predict hypertension, and they found 82% of accuracy. Where reference 4 developed 4 model of statistical algorithm by using multilayer perceptron, and they compared the 2 artificial neural network models, and among their multilayer models, MLP and RBF had the same and the topmost performances. Another reference 5, we can see that they used artificial neural network based high blood pressure risk prediction system, and Java applet was designed to the interface between artificial neural network system and end user, and they got 75% of accuracy. So we have seen that many people actually worked on hypertension, and they used the state-of-the-art classifiers like artificial neural network, support vector machine, and so on to predict hypertension, but they didn't optimize hyperparameters. But we know that hyperparameter optimization is very necessary to predict hypertension. So this is the research gap that we are going to fulfill in our work. Well, so we have proposed Gray-Wolf optimization based XGBoost classifier for our work. We know that Gray-Wolf optimization is a meta-heuristic swarm intelligence algorithm, and Gray wolves are the top predators of food chain, and they maintain some social hierarchy and hunting strategy. And the second objective of our paper is to compare the performance of our Gray-Wolf optimization based XGBoost with the other classifiers. So these are the objectives of our paper. We can see here a block diagram that is actually our proposed methodology. So first of all, we have to load our data set, and then we will pre-process it using our domain knowledge. After that, we have to extract the important 8 features from our data set. And then we divided the dataset into training data and test data using train test split method. Then we used XGBoost method on our training data and optimized its parameters. And finally, we evaluated our optimized model on our test data. So lastly, we compared our Gray-Wolf optimization based XGBoost model with the other state-of-the-art classifiers. Here we can see that we have collected our data from Bangladesh Demographical and Health Service of 2017-18, and we selected 8 variables among the 321 variables. And in the data processing section, k-nearest neighbors algorithm was applied where k equals to 5, and we performed synthetic minority oversampling technique to balance our data set. XGBoost classifier is a decision tree-based ensemble machine learning algorithm that efficiently handle missing data. And we know that hyperparameter of the XGBoost model controls the classification performance. So we selected these 8 hyperparameters that should be optimized using our gray wolf optimization technique. So the parameters are learning rate, co-sample by tree, mean split loss, next step, mean child weight, subsample alpha, and eval metric. Optimization technique is the gray wolf optimization technique that is used here to optimize the hyperparameters. It's a novel heuristic swarm intelligence optimization algorithm. So let's have a look on the bio-inspired algorithm of gray wolf optimization based XGBoost. Here we have optimized the hyperparameters. So in the input section, we have first fixed the search agent maximum iteration upper bound, lower bound of the hyperparameters. And the output will be obviously the gray wolf optimization based XGBoost model. So firstly, we initialized the population of hyperparameters and the position adjusting vectors. Then we calculated the fit function for each search agent. Then we called the while and for loop. And after that, we updated the position adjusting vector and calculated the fit score for all search agents. And as we have 8 hyperparameters, that is, it's a 8-dimensional search is performed here. So after optimizing the hyperparameters, we have got the optimal values of the XGBoost hyperparameter. And using this value, we will predict hypertension more perfectly, optimizing our XGBoost model. Here in this table, we can visualize the comparison of the performance between the state-of-the-art classifiers. It actually shows that our gray wolf optimization based XGBoost provides the better result among all the other classifiers. In case of accuracy, error score, F1 kappa score, we can see that gray wolf optimization based XGBoost has the highest scores comparatively. So here's the confusion matrix that actually visualizes the class-wise performance of the gray wolf optimization-based XGBoost. We can see that the diagonal elements shows the correct values and the non-diagonal elements shows the misspecific Fisher values for the actual and predicted yes or no hypertension. Bootstrap ROC curve represent model's biasness. We basically got 86% of mean area under curve in this case. Precision recall curve, it compares our GW-XGB model with the other models, and as much the higher area under curve, as much the value of precision and recall value. We actually not only classify hypertension, but also show the feature importance. We can see 7 most relevant features are extracted from the BDSS dataset, where sex of our household member is the most significant feature and the least significant feature is division. We can say that division, variation in division has least effect on hypertension. Conclusion. Gray wolf optimization based XGBoost model is used to predict hypertension. And prediction is based on socioeconomic factors of our dataset. XGBoost performed maximum accuracy of 91.26%, and hyperparameters of XGBoost is optimized with the gray wolf optimization. After that, significant features are extracted by the feature importance score. So, as a lot of people die every year due to hypertension, our proposed system may decrease this rate by detecting hypertension earlier and reduce the mortality rates also. These are the references we have used in our paper. Thank you.